Today we're going to be learning about graphing in the form f of x equals a times x minus p times x minus q. This is intercept form. It's also called factored form of a quadratic. Now the x-intercepts are the roots, and those are p and q. The axis of symmetry is going to be exactly in between these 2 points, p comma 0 and q comma 0. And the equation for this, since it's the average, when we find the average of two numbers, we add them and we divide by 2. So if I had the two numbers 7 and 9, if I were going to find a number right in between, I'd add 7 plus 9, which is 16, divide by 2, that gives me 8. 8 is right in between 7 and 9. The graph is going to open up if a is positive, and it's going to open down if a is negative. Now we can remember our happy smiley face for positive and our frowny face for negative. Here's an example. I have my a is -1, my p is -1. Now how we get that, remember when we set them equal to 0, we do the opposite sign. So if I have x plus 1 equals 0, I subtract 1 from both sides and I get x equals -1. And if I have x minus 5 equals 0, I add 5 to both sides and I get x. My q is equal to 5. So my 2 points, I have -1, 0 and 5, 0. The axis of symmetry is going to be right in between those two numbers. Now I can add -1 plus 5 and divide it by 2. And I get -1 plus 5 is 4. If I divide that by 2, I get 2. So that's halfway in between. The vertex is going to be 2. Now to find the y part of the vertex, I'm going to plug it into the original equation. So everywhere there's an x, I'm going to put a 2. So I have -1 times x plus 1 times x minus 5. In for x, I'm going to put a 2. So 2 plus 1 gives me 3. 2 minus 5 is -3. 3 times -3 is -9, but we have that negative out front, which gives us a positive 9. So we graph that point, and we have the 2 zeros. We connect those with the smooth curve, and that's our parabola. Right here, we've got the success criteria for graphing these equations. We're identifying A, P, and Q. We're plotting the x-intercepts, finding the axis of symmetry. Then we find the y-coordinate of the vertex and plot the vertex. Then we connect those points with that smooth curve, which is a parabolic shape. Okay, let's go ahead and look at some practice problems. Our first one, we have x minus 1 and x minus 5. Now, if we were to put a 0 in for the y, remember the y-axis is, if the y is 0, we are on the x-axis, and that would give us our x-intercepts. So if our answer is 0, we're going to set each piece equal to 0, x minus 1 equals 0, and x minus 5 equals 0. And so x is going to equal 1 and x is going to equal 5. And those are going to be our two x-intercepts. We're going to have one at 1 and one at 5. Now, if we wrote these as points, we would have the point, we would go over first, over 1 up 0, and over 5 up 0. Our axis of symmetry is going to be right in between. So you can either look at it and find what's right in between. That would be 1, 2, 3. At 3, x equals 3. Another way you could do it, if it's a harder one or if it's not exactly in between, is what you do is you add these up. 1 plus 5. 1 plus 5 equals 6. And then we would divide it by 2. We would take the average of our x's. You add them up and divide by how many you have. And if you take 6 divided by 2, that also gives you 3. So I'm just going to draw my axis of symmetry in here. My vertex is always on the axis of symmetry. So my first number is going to be a 3. And to get the second one, we take that 3 and we plug it into the equation, and that will give us our y value. So if you have f of x equals x minus 1 times x minus 5, what you're going to do is you're going to put a 3 in everywhere there's an x, which would be 3 minus 1 times 3 minus 5, which is 2 times negative 2, which equals negative 4. So I'm going to go over 3 down 4 and put my vertex, and then you could just combine, and then you just connect the dots into a smooth parabola shape. Now this is concave up, it's pointing up. And so if you have a pit, you're in the bottom of a pit, you're at a minimum point. So this is going to be a minimum. Domains for parabolas, we can put any number in for x. This is going to give us all real numbers. Our range are our y values. The y starts all the way at negative 4. There's nothing below negative 4. It starts at negative 4 and it's everything above negative 4. So we're going to say y is greater than or equal to negative 4. On example 2, we're going to take our x-intercepts by setting each of these pieces equal to 0. We're going to put a 0 in for y to find the x-intercepts. And then we have x plus 1 equals 0. We minus 1. That gives us the opposite. So if we have a plus 1 here, we're going to have one at x-intercept at negative 1. And then if we take the x minus 3 and set it equal to 0, we add 3 to both sides. So we also have one at positive 3. If we wrote the as points, we would have negative 1, 0, and 3, 0. You can look at it and find where it is right in between for the axis of symmetry. That would be at x equals 1. Or you can take our x values, negative 1 plus 3, add them together, and then divide by how many you have. You have 2. That would equal 2 divided by 2, which equals 1. So you get 1 either way you do it. The vertex is always on that axis of symmetry. Let's draw that in. So our first point is 1. To get the y value, we're going to take the 1 and plug it into the equation. So I'm going to have negative 2, plug a 1 in for the every x. You could put that into your calculator or you can do it by hand. And then we're going to get a positive 8. Now this one's just slightly off the graph. That's okay. And then we just, best we can, do a smooth curve. Now this one looks like kind of like a mountain, and if you were standing on top of a mountain, you would be at a maximum point. So this parabola has a maximum. Domains, again, for all parabolas are all real numbers. And then to find the range, this range is the y values. It goes all the way up to 8, and it's everything below 8. There's nothing up above that. So we're just going to say that y is going to be less than or equal to 8. 8's the highest point that goes. Okay, now this one, if we put a 0 in for the y, or the f of x, which is another way of saying y, we're going to set each piece equal to 0. We say x equals 0 and x plus 4 equals 0. We have an intercept at 0, but we also have one at negative 4, because if we minus 4 from both sides, that would give us a negative 4. So we have one at 0 and one at 4, negative 4. So if we were to write this as points, we would have negative 4, 0 and 0, 0. Our axis of symmetry is going to be right in between the 2 points at x equals negative 2. But remember, you can add the x values. Negative 4 plus 0 is negative 4, and then we divide that by 2. and negative 4 divided by 2 is negative 2. So either way, you get a negative 2 for the axis of symmetry. The vertex is always on top of the axis of symmetry, so we put a negative 2 in, and then we plug that into the equation. Our equation is x times x plus 4, but we're putting a negative 2 in everywhere there's an x. This gives us negative 2 times 2, which equals a negative 4. So we have the point negative 2, negative 4. We take our graph and we connect it into a smooth curve. Looks like a parabola, just best you can. It is going to have a minimum because if it was a pit, you would have someone down in the pit. They would be at a minimum point. Domain is always all real numbers. I'm going to use this fancy R symbol that just represents all real numbers. And the range, the lowest point that it goes to is negative 4. We're looking at everything above negative 4. The graph is all the way above negative 4. It keeps going up forever. So we will just say y is greater than or equal to negative 4. So if we're finding on number 4, we're going to find the x-intercepts. We're going to put a 0 in for the y. Now 1/3 will not equal 0. So we don't need to look at that part. We just need to look at the x and the x minus 6 and set both of those equal to 0. So x is equal to 0, and if we add 6 to both sides, our x is going to equal 6. So our x-intercepts are at 0 and 6. If we wrote that as points, we'd have the point 0, 0 and 6, 0. Our axis of symmetry is going to be right in between those two, which is at 3. So we have x equals 3. The other thing we could do is add 0 plus 6 together and then divide it by 2 to find the average. And 6 divided by 2 would also equal 3. So we got that number if you didn't want to count in between. You would add them up and divide by 2. The vertex, the first number is always on the axis of symmetry, so it's a 3. And to get the second number, we're going to plug it into the equation. So we look at this equation up here. Take this equation, and then we're going to plug our x, and we're going to take that 3 and plug it in everywhere there's an x. So we have 1/3 times 3 and 3 minus 6. This gives us a negative 3. So our vertex is at 3, negative 3. And then you connect the points in a smooth curve. Since this looks like a pit, if you were at the bottom of a pit, you would be at a minimum point. Domain for parabolas is always all real numbers. You can write that fancy R, and that just means all real numbers. And then the range, it goes all the way down to negative 3, but there's no graph below negative 3. So the y has to be greater than or equal to negative 3.